I want to show you how to draw a uniform velocity cam. A cam transfers motion perpendicularly. We're going to take a cam, imagine it is on a shaft straight down the center lines of this circle. And as we turn the shaft, depending upon the profile appearance of the cam, this follower is going to rise and fall. Again, we're going to do what's called uniform velocity. And what I've done is I've taken the circumference of the base circle of the cam and divided that up into 12 equal units. And then I've created a line that is representative of that circumference. It doesn't have to be the exact length. What I usually use is about 3 times whatever the uh, base circle diameter is. Here, what I'm using is a 3-inch diameter base circle, so I used a 9-inch long line. Normally that would be 3 times pi to get that true length, but we don't need the true length. I'm also looking to have the cam rise a total of 2 inches over 180 degrees and then return to its starting position over the final 180 degrees. And it's called uniform motion because, or excuse me, uniform velocity, because this thing is going to maintain that exact same speed the whole time it's going up and coming down. Um, what we do to figure out where we're going to be when we get 15 degrees, which is 360 divided by 12, or not 15 degrees, excuse me, 30 degrees, is here is 1/12 of the way, and this is how far away I am. So what I'm going to do is use this distance and offset the base circle, and then extend this line out to hit that circle, and that's where I'll be 30 degrees around the rotation. Then I will offset this distance, the base circle, and extend this line out to hit it, and that's where I'll be when I go 60 degrees around the cam. If we look at this uniform motion, what's going to happen is each one of these increments all the way around is the exact same distance away from the previous one because we've got just a single angle. Um, the distance from here to here is equal to the distance from here to here. So I can just keep offsetting the circle, the new circle, this distance until I get 6 circles away, which will be 180 degrees. So I'm going to type in O for the offset command, and I'm going to set my offset distance by picking 2 points because I don't know the exact number. So I'm going to pick there and I'm going to pick there. And then I'm going to take my base circle and offset it. And then I'm just going to keep offsetting that same exact distance 3, 4, 5, 6 times. And now when I get 1, 2, 3, 4, 5, 6/12 of the way around, I'm going to be this far away. So this will make sense as we kind of map this out. Now what I'm going to do is use my extend command and extend each one of those lines that I've arrayed out to the next circle. So EX is a shortcut for extend, and then hitting enter makes everything a boundary edge. And I'm going to extend to here, and this one twice, this one 3 times, and this one 4 times, and this one 5 times, and this one 6 times. And I got to move and make sure I get closer to this other endpoint. And there we go. Now I could keep doing that 5 times, 4 times, 3 times, but I'm kind of tired of that. So I'm just going to pick all of these. Oops, I've got them. It doesn't make sense. I shouldn't have done that. Well, uh, hmm, I don't know why that's highlighting the whole thing. Okay, we'll just keep doing our extending I don't know why these lines are duplicating or why that one is anyway. Oh, I know why, because I picked it and sent it in the wrong direction. Okay, that makes sense to me. Just ignore me. And I'll go to there, and then I'll go to the third one, and then I'll go to the second one, and then I'll go to the first one. And now, using the spline tool, if I just connect all these endpoints, I'll have my cam. So I will do SPL, that's a shortcut for spline. And I'm going to start my spline right here. And then first thing I'm going to do is kind of uh, set the tangent direction. I don't want to go immediately up. I'm going to kind of smooth it away from here horizontally and then go up to that point. So I'm going to set my tangency direction in this direction, and then I'm going to go up to here and then out to this one, and I'm making sure that I keep getting endpoints and not object snap locations, or excuse me, polar tracking angle locations. Just making sure I get to the endpoint of each one of those lines. And we're getting there. That's an intersection, and that's there. And now I'm going to go back to here, and then I'm going to smooth that out also by adjusting the end tangency and going nice and smooth here. And we'll zoom out, and that's what our cam looks like. You can see that we're going in a uniform accelerated motion till we get all the way out here. We did smooth it out ever so slightly so that it's not just kind of forming a peak right here. We just smooth that out using tangency. But you can see that that is going to be kind of pretty harsh as it turns direction, because not only is it increasing right here, as soon as it, or speed-wise, it kind of stays the same, but then as it turns down, it stays the same also. So even that's kind of harsh on this side. We'll talk in the next video about modified uniform velocity cams, which just kind of smooth out the starting, pulling away and coming back down.